Go ahead, all yours.
All right. Good morning, everyone. Okay, show of hands. Who all had, well, not yet, please. I haven't asked the question. Who all never heard of Postgres before just now? Oh, wow. Not a single hand up. Excellent. 10 years ago, when I would ask this question to a hall full of people, pretty much every hand would go up. Right? And I'm very glad to see that absolutely no hand went up in this room right here. And that does go on to show how much an increase in popularity the Postgres database has had over the years. Right? And as Arthur introduced me, I've been working in the Postgres ecosystem for more than 2 decades. That's what I've done as my day job. That's what I've done as my volunteer efforts. And that's where I built my company, Stomatics, 3 years ago. We're focused on providing professional services for Postgres. And I'm going to just pick up where Arthur left off about customization at scale and do a deep dive into Postgres and how we could possibly customize Postgres at scale. And there's another reason why we're talking about Postgres specifically as the database, because increasingly it is showing up to be the database of choice for AI deployments, for AI app development. And it tends to be hidden behind a few layers of platforms, and hence you might not know that you're working with Postgres. So as an example, Supabase, every lovable app that you've ever created is deployed on Supabase. It tends to be the platform of choice for any AI developer. This is a post that Paul Copplestone made about a month ago on LinkedIn, and he showed that it took them 5 years to go from 0 to 1 million users, and then just 1 year to go from 1 million to 7 million. In the words of their chief customer officer, we're drowning in our own success. Right? So absolutely crazy. I mean, if you want to teach somebody what a hockey stick growth looks like, show them this graph. So that's Supabase. Supabase, by the way, if you don't know, it's entirely built on Postgres. It's a platform that's built on top of the Postgres database. So if you're using Supabase, you're using Postgres. And then there's another tool in the AI world that is, well, it's popular. You guys might have heard of it. Some of you might have even used it. It's called ChatGPT. Right? So ChatGPT completely deployed on Postgres. They've got 50 instances of Postgres distributed across the world that service 800 million users and millions of queries per second. They published a paper on their website, that's the URL if you want to take a look at it, in which they talk about how they scaled. Right? And I came across this website, amplifying.ai, had some very interesting research on it. It publishes the default tooling that LLMs and AI agents might use depending on what problem it is that you're trying to solve with them. So if you ask an LLM to create an application stack for you, the likelihood of choosing a tool is what they measure. So as an example, if it is CI/CD that you want, they're probably going to use GitHub Actions. If there's a payment integration that they want to build, they're probably going to use Stripe. In case of databases, 58% chances are that they're going to use Postgres, and 24% chances they're going to use Supabase. Combined, you're looking at an 82% likelihood that you're going to be working with Postgres. Now, why is this important? We're getting so much deployment and so much application development on Postgres, but who is managing Postgres? Who's helping with Postgres? And I'll tell you what the problem is. So when you deploy Postgres in a serious production environment and you're trying to scale it, there are various factors that you need to keep in mind and you need to evaluate before you make a design and make the deployment. Typically, organizations think about 6 axes, with each axis having certain values, and combined, they end up with 2,160 possible combinations that they could deploy with. Now, this number is way too big for anybody to be able to evaluate thoroughly and then deploy, and customization has always been a luxury. It takes a long time to evaluate what combination would serve you best, and then actually deploy it, and then tune it, and then monitor it and manage it. And if, oh boy, if something goes wrong, what do you do? Right? So the choice had always been, you pick a combination, and then you stick with it. And then you modify and mold your use case be paired with that deployment. Now, with managed services on the cloud and Kubernetes and containerization, it took you a step further. It allowed you to choose from a few additional templates, so now you have more choice. With the advent of AI, however, the game has changed. Now you can actually look at customization because the unit economics have changed. Here's my thesis. I think that we can take our expertise. At Stomatics, we have more than 130 years of combined Postgres experience. I think we can take that experience, we can amplify it using AI, and we can customize Postgres for every deployment at the cost of cookie cutter approaches. That's the thesis. Now, remember we talked about 2,160 combinations. Let me help you visualize this a little bit. I hope this plays. There you go. So we have this interface up on our website. On the left pane, you have those axes that I talked about and all the possible combinations. And on the right side, it will help you visualize what the architecture is going to look like depending on what you choose. So you can pick and choose depending on what your use case is. And once the architecture is deployed or is designed, the agent can go ahead and deploy it because the agents are trained to do exactly that. If you want to take a look, that's the QR code of our website. So the idea is to just simplify the effort of choosing what architecture to use and how to deploy your database and make it very visual in nature because you're able to see exactly what you're choosing. Now, once the deployment is done, once the database is out there and up and running, now we are talking about day 2 operations because that's just the start of your database journey. It doesn't end there, it just starts there. Now the database is deployed. What happens when you want to manage it and when you want to maintain it? We used to offer a service that we called the quarterly health check, in which a consultant would go in, we would analyze the log files, the database configuration, the workloads of the organization, and we'll figure out what needs to be fixed. And it will take about a week worth of effort, and we'll come up with a report that gave recommendations to the organization on what to tweak and what to tune and how to do it. Now, with the advent of AI, we were able to squeeze that 1 week effort into a single day. Tremendous achievement, but we're not stopping there. With the way the tooling is evolving and with what is possible today, what we're looking at is continuous monitoring and tuning. So agents reside with your database. They're analyzing your workloads and the database performance in real time and constantly fine-tuning the database. Now, what we are not able to do with humans is somebody just sitting in front of a screen, looking at the dashboards 24 hours a day, 7 days a week, and just making those tweaks. The human cost is way too high. With AI, however, don't even need to think about it. It's almost like a given. But day 2 operations are not just about maintenance or preventive maintenance. The Constitution says that people are innocent until proven guilty. Unfortunately, the Constitution does not cover databases. More often than not, each time something goes wrong in your application stack, the database gets the blame. And over time, we've come up with this metric that we call mean time to proven innocence. We need to prove that the database is not at fault. If you get into a car crash, more likely that the car was not at fault, right? It was the driver's. But we also need to figure out what it was that went wrong and then nail it down to make sure that it doesn't happen again. And that triage process, the act of troubleshooting, gets condensed to seconds and minutes instead of hours and days with the help of AI, with the help of these agents. Now, what was unthinkable yesterday is possible today and is going to be taken for granted tomorrow. That's where we're headed. And what I displayed to you, what I demonstrated to you just now, it's not just a vision or a dream. It is real. It is what we're doing today. And we're offering it as Stomatics DBA as a service. And we have paying customers that are leveraging this service and getting benefit from it. We say that AI has raised the floor. We're here to raise the ceiling. If you're using Postgres in production, let's talk. That's the QR code to my LinkedIn. Happy to take any questions that anybody might have.
Thanks, Umair. Any questions for Umair? Awesome. So I guess this is what it looks like when you take really deep expertise in something niche and start to look at that. Lance, you had a question? Go ahead.
So when I started working with Postgres, and up until pretty deep in my career, we did see a lot of migrations, especially from Oracle to Postgres. We do see some from SQL Server to Postgres. We're now getting pinged for DB2 to Postgres. Right? And the primary driver is they say, we cannot find DB2 expertise anymore. We've got to do something. And the destination database tends to be, the favorite tends to be Postgres. But I would say that most of the demand comes from new applications, not from legacy applications. So the new application development, more often than not, is happening on Postgres. Legacy applications, think about large-scale deployments. It's very hard to rip out the core of your application and replace it with something else, and it takes guts to do that. Few organizations are able to do that. Okay. So there's a website, authoritative websites by the name of dbengines.com. They track database usage and demand across the world, and they've been doing it for the past 12 years. Right? So year over year, you can see trend graphs. Over the past 12 years, Postgres, Snowflake, and Databricks are the only platforms that are consistently rising in popularity and usage. Everything else, including Mongo, is going down. Right? The trends are very clear. So the answer is going to be very similar to what I said.
Umair, can you repeat the question? Just for everyone.
Okay. So the question was, the gentleman here was surprised to see no mention of Mongo in the graphs of the data that I showed earlier. And he was asking if we've seen any trend of migration from Mongo to Postgres. So the answer is very similar. Some, yes, but typically, if an application is already developed and deployed, it's hard to rip out the core, and very few organizations venture into that. But new application development, we are seeing organizations choose Postgres over Mongo increasingly. Yes, that's a very interesting question, and I know that the entire Vixul community is working very hard on that. So absolutely, I think that increasingly what we're seeing is that the T&M model does not work anymore. Right? And for a variety of reasons, one of them is I can throw my best person at a problem who can solve it at, let's say, 5 hours, and I get to charge 5 hours for it. Or I can throw a newbie at that problem who will take a week to come up with a solution which may or may not work, and I can charge 40 hours for it. But that doesn't sound fair. Right? I'm making more money with the newbie, but the actual value that I'm delivering is more for the seasoned expert. So the T&M model doesn't quite work like that. It has to be value-driven. It has to be outcome-driven. Yeah.
All right. Thank you so much, Umair, for sharing the stuff. And as I said earlier, during the break, Umair would be available in the demo area if you would like to see more of what you just saw here or have any questions for him. So thank you, Umair.
Sure.